Projective Geometry, Volume 1, by Oswald Veblen and John Wesley Young.
Chapter 4, Harmonic Constructions and the Fundamental Theorem of Projective Geometry. Section 31, Harmonic Sets. Definition: a quadrangular set Q of 1, 2, 3, 1, 2, 4 is called a harmonic set and is denoted by H of 1, 2, 3, 4. The elements 3 and 4 are called harmonic conjugates with respect to the elements 1 and 2, and 3 or 4 is called the harmonic conjugate of 4 or 3 with respect to 1 and 2. From this definition, we see that in a harmonic set of points, H of AC, BD, the points A and C are diagonal points of a complete quadrangle, while the points B and D are the intersections of the remaining two opposite sides of the quadrangle with the line AC, figure 34. Likewise, in a harmonic set of lines, H of AC, BD, the lines A and C are two diagonal lines of a complete quadrilateral, while the lines B and D are the lines joining the remaining pairs of opposite vertices of the quadrilateral to the point of intersection AC of the lines A and C, figure 35. The harmonic set of planes is the space dual of a harmonic set of points and is therefore the projection from a point of a harmonic set of lines. In the case the diagonal points of a complete quadrangle are collinear, any 3 points of a line form a harmonic set, and any point is its own harmonic conjugate with regard to any 2 points collinear with it. Theorems on harmonic sets are therefore trivial in those spaces for which assumption H0 is not true. We shall therefore base our reasoning in this and the following 2 sections on assumption H0. Though most of the theorems are obviously true, also in the case H0 is false. This is why some of the theorems are labeled as dependent on assumptions A and E, whereas the proofs given involve H0 also. The corollary of Theorem 3, Chapter 2, when applied to harmonic sets, yields the following. Theorem 2, the harmonic conjugate of an element with respect to 2 other elements of a one-dimensional primitive form is a unique element of the form. Assumptions A and E. Theorem 1 applied to the special case of harmonic sets gives Theorem 3. Any section or projection of a harmonic set is a harmonic set. Assumptions A and E. Corollary. If a set of 4 elements of any one-dimensional primitive form is projective with a harmonic set, it is itself a harmonic set. Assumptions A and E. Theorem 4. If 1 and 2 are harmonic conjugates with respect to 3 and 4, 3 and 4 are harmonic conjugates with respect to 1 and 2. Assumptions A, E, and H0. Proof. By Theorem 2 of Chapter 3, there exists a projectivity 1, 2, 3, 4, projective with 3, 4, 1, 2. But by hypothesis, we have H of 3, 4, 1, 2. Hence, by the corollary of Theorem 3, we have H of 1, 2, 3, 4. By virtue of this theorem, the pairs 1, 2, and 3, 4 in the expression H 1, 2, 3, 4 play the same role and may be interchanged. Footnote: the corresponding theorem for the more general expression Q of 1, 2, 3, 4, 5, 6 cannot be derived without the use of an additional assumption, chiefly Theorem 24 of Chapter 4. Theorem 5, given 2 harmonic sets, H of 1, 2, 3, 4, and H of 1', 2', 3', 4', there exists a projectivity such that 1, 2, 3, 4 is projective with 1', 2', 3', 4'. Assumptions A and E. Proof. Any projectivity 1, 2, 3 projective with 1', 2', 3', by Theorem 1 of Chapter 3 must transform 4 into 4' by virtue of Theorem 3 corollary, and the fact that the harmonic conjugate of 3 with respect to 1 and 2 is unique, Theorem 2, This is the converse of Theorem 3 corollary. Corollary 1. If h of 1, 2, 3, 4 and h of 1, 2 prime, 3 prime, 4 prime are two harmonic sets of different one-dimensional forms having the element 1 in common, we have 1, 2, 3, 4 is a perspectivity with 1, 2 prime, 3 prime, 4 prime. Assumptions A and E. For under the hypothesis of the corollary, the projectivity 1, 2, 3 projective with 1 prime, 2 prime, 3 prime of the preceding proof may be replaced by the perspectivity 1, 2, 3 is perspective with 1, 2 prime, 3 prime. Corollary 2. If h of 1, 2, 3, 4 is a harmonic set, there exists a projectivity 1, 2, 3, 4 projective with 1, 2, 4, 3. Assumptions A and E. This follows directly from the last theorem and the evident fact that if h of 1, 2, 3, 4, we have also h of 1, 2, 4, 3. The converse of this corollary is likewise valid. The proof, however, is given later in this chapter, chiefly Theorem 27, Corollary 5. We see as a result of the last corollary and Theorem 2 of Chapter 3 that if we have h of 1, 2, 3, 4, there exist projectivities which will transform 1, 2, 3, 4 into any one of the 8 permutations 1, 2, 3, 4, 1, 2, 4, 3, 2, 1, 3, 4, 2, 1, 4, 3, 3, 4, 1, 2, 3, 4, 2, 1, 4, 3, 1, 2, 4, 3, 2, 1. In other words, if we have h of 1, 2, 3, 4, we have likewise h of 1, 2, 4, 3, h of 2, 1, 3, 4, h of 2, 1, 4, 3, h of 3, 4, 1, 2, h of 3, 4, 2, 1, h of 4, 3, 1, 2, h of 4, 3, 2, 1. Footnote, these transformations form the so-called 8 group. Theorem 6. The two sides of a complete quadrangle which meet in a diagonal point are harmonic conjugates with respect to the two sides of the diagonal triangle which meet in this point. Assumptions A and E. Proof. The four sides of the complete quadrangle, which do not pass through the diagonal point in question, form a quadrilateral which defines the set of four lines mentioned as harmonic in the way indicated. Figure 36. It is sometimes convenient to speak of the pair of elements of a form as harmonic with a pair of elements of a form of different kind. For example, we may say that two points are harmonic with two lines in a plane with the points, if the points determine two lines through the intersection of the given lines which are harmonic with the latter. Or, what is the same thing, if the line joining the points meets the lines in 2 points harmonic with the given points. With this understanding, we may restate the last theorem as follows. The sides of a complete quadrangle which meet in a diagonal point are harmonic with the other two diagonal points. In like manner, we may say that 2 points are harmonic with 2 planes if the line joining the points meets the planes in a pair of points harmonic with the given points, and a pair of lines is harmonic with a pair of lines if they intersect on the intersection of the 2 planes, and if they determine with this intersection 2 planes harmonic with the given planes.
Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renholt, with programming and illustration by Jim Renholt, 2019. Thank you for listening.